So good evening, and I thank the Tyagaraja College of Engineering, IEEE chapter for inviting me to give this talk. And it's nice that you are organizing these lectures during this time when we don't have communication among ourselves, so we cannot meet physically. So I think there are a lot of online lectures. This is one of those. So I chose a topic that is kind of a general nature called engineering temper. And as just noted, this is something that is on everybody's mind. We are an engineer. We think about what is engineering that we do. And I just wanted to talk about that. Even though I'm from Institute of Science, I'm a mechanical engineer because, as you know, IISc has engineering and science. But then we always get confused between science, engineering, and technology. And that is what I would like to clarify today. And I don't know how to get rid of this. Maybe it stays, or how does it go away? Okay, anyway, okay. I just have a few questions, before we begin. And the first question is, can you recall some roads or buildings or auditoria named after engineers? You can think for yourself. So usually most of the roads in India are after freedom fighters and politicians normally. And in some countries, they would have people other than freedom fighters and politicians, and sometimes famous people of whatever kind. Some cricketers. There are some roads in Bangalore that named after cricketers. But can you recall some roads named after engineers? Right? To name after somebody, that person should have been distinguished. Right? Maybe you would think of some people. And when colleges or universities, when they name buildings or auditoria or halls, right? So usually there'll be Newton Hall or this hall or that hall. So can you think of some auditorium that is named after engineers? That's the first question for you. And next thing is, when is Engineers Day celebrated in India? Can anyone answer? You can maybe unmute and say.
So all the participants can unmute themselves and answer.
Yeah, one or two is enough if you know the answer.
September 15, sir. September 15, sir.
September 15, because
Vishweshwaraya's birthday.
Yeah, it is Vishweshwaraya's birthday. That's what we do. And what about in the US? Because US wouldn't celebrate Vishwesharaya. So when is their Engineers Day? Well, I mean, every country will have one day. So in the US, it is celebrated for George Washington's birthday, because George Washington, the first president, was a surveyor, so like a civil engineer. So they celebrated in February to coincide with his birthday, which is 22nd of February. So that whatever week that 22nd falls, they celebrate as the Engineers Week there. So some great engineers are actually celebrated in their respective countries, right? But not as much as one would like to see, whereas scientists are celebrated a lot more than engineers. So one question arises is, what do engineers do really? So scientists, society seems to understand, but engineers, when you say, are these people who simply do some work that is given to them? For example, we just talked about Vishwesharaya, right? So he was a great engineer. And when you look at Krishna Sagar Dam in Mysore, you'd say, yeah, he built it, or he designed it, or he created it, right? That's what we say. But then today, when we think of some equally great engineering structures like this Bandra link, who created that thing? If you say that bridge, right? Probably there is no one name that you can give. You'll say there are a lot of engineers. Somebody designed, somebody planned it, somebody built it. So it's not like one person's conception. So engineering now has become more like a team activity. It's not one person that we can say this person has created this. Okay? That is probably one of the issues that we have to deal with, right? Whereas scientists are associated with a single thing, and we can say, yeah, he or she did it. but we can't easily say that for an engineer. So if I really ask this question, can you name some great engineers? Here is a world map. You can pick your country and name, if you know, a great engineer from that country. Or I've listed a few countries, India. Whenever I ask anyone to name a great engineer from India, Vishweshwaraya's name comes first. Okay, and then a few other names come. So can you actually say some other names? If you want, you can type in that chat box from these countries, from the United States of America, from England, from France, Australia, Germany, Russia. You pick a country, Brazil, wherever. Pick some names of engineers who are famous in their countries. Vishwesharaya was a great engineer for us, but if you ask somebody else, they wouldn't know. But C.V. Raman is a scientist from India. A lot of other country people also would know. So engineers are known within their country. So if I ask who was a famous engineer from France, I don't know how many of you can name an engineer from France or Australia or Germany or Russia. So are there any names there? Maybe somebody can see in the chat box, or you can say some names from India other than Vishwesharaya. Who are the other great engineers that you know of? Yeah, let's make it interactive because we can't see each other. So at least we can speak, right? Anyone? Any of these countries or just from India itself?
Alexander Eiffel.
Eiffel from France, yes. Yeah, he was a great engineer. Yeah. And any others? From France, we have a name. From Australia or England? Yeah, Eiffel is famous for his tower, right? So other people are past and they're forgotten. But people like Newton, Einstein, C.V. Raman, they're not forgotten ever, right? All countries would know them. Okay. So there is a difference between the way society views scientists and engineers. Okay. So I just got this now. This is a book published by Indian National Academy of Engineering. So this is INAE is in our country the respected body, an academy of engineering. Okay, they published a book called The Mind of an Engineer. I got this book and looked at it eagerly to see whether I can understand what is the mind of an engineer. And the back cover of this book says this: INAE promotes the endeavor of the practitioners of engineering and technology and related sciences. So INAE puts in related sciences. Technology is fine. Engineering and technology go together, but and say unrelated sciences to solve the problem, national importance, all that. And then let's say this book is an initiative of the INAE and a reflection of the experiences of some of the fellows of INAE, the fields of, again, science and technology engineering. So engineers ourselves, we are not able to dissociate ourselves from science. We always feel that we get more respect if we say we are doing science rather than engineering and technology, especially in academia. There is something that we need to take note of. Somehow science is put on a high table compared to engineering and technology. And this book I flipped through. There are 58 articles in this written by very distinguished people. Mostly they're biographical. They talk about their own journey as a researcher or a person in the industry. There are both kinds here. But then I didn't get much of the mind of an engineer from this book, I must say. And then they published another volume. This came recently in 20, The Mind of an Engineer, Volume 2. Again from INAE, published INAE and Springer. So there, one article attracted my attention. That is by S.S. Chakraborty. He is an engineer working in the industry, Trans-Asia Infrastructure Private Limited, New Delhi. And the title of his chapter in this book is Engineers Preeminent in Society. And it is a wonderful article written by this gentleman, S.S. Chakraborty, and where he doesn't talk about himself, unlike the other articles that are there in these books. 2 volumes, more than 100 articles. Mostly people talk about their journey, where they graduated, what they did. Whereas this particular gentleman actually talked about engineering in a general fashion without talking about himself. And there was something that was very interesting that he starts out. by asking about engineers. Who are they? Are they so special that they need to be recognized as a separate breed? He asks. So I'm giving this talk to tell you about engineering temper, as if engineering temper is important, right? So there are people who, for example, there are bakers who make bread. There are cooks who cook food. There are laundry people who, wash clothes. So every profession is important. But why should society recognize them as a separate breed like we do for scientists? Scientists are respected. Are engineers respected? So he asks, are engineers so special they need to be recognized as a separate breed? Who do they serve? Who do engineers serve? Are also like clerks, where they go at 9 o'clock in the morning, work till 5 o'clock, and come home by serving basically the administration? Are they like clerks? Or do they guide somebody? And what is their purpose? And finally, what is their status in society? That's what he pointedly asks. What is the status of engineers in our society today? And he actually says this: to get society to glorify engineering, engineers have to become visionaries within the constraint of time, space, and money, and yet follow the professional standards. So he says a lot here. So whenever you think of, and as some great engineers, two names came up: Vishwesvaraya did a lot of city planning for the state of Mysore and Karnataka now, and built Krishnarasagar Dam and a lot of Mysore sandal soap factory and a lot of other things, right? So he was a visionary. So it's not just engineer, but he was a visionary. To get the society to glorify engineering, engineers have to become visionaries. That scientists don't have to do. They just need to find something. Okay, but engineers also have constraints of time, space, and money. If I want to build a dam or a metro rail thing, right? I have constraint of how much space I can occupy, how much money do I have, how much time do I have to do this, and there are professional standards one has to follow. And engineers are considered to be creators. So he says, creation actually ties in well with this type of visionary thinking. And he also wonders, if you say creators, creativity is something that we attribute to artists and not necessarily to scientists or engineers and technology people. But he says, unlike artists, engineers are constrained by their profession and their perceived duty to society. Artists basically have to entertain and create a piece of art that we enjoy, but there is no perceived duty to society, whereas engineers have. When you build a building or a big bridge or a dam or a tower or whatever, right? There is a perceived duty to society. And he finally says the unwanted, underserved relegation of engineers in society hierarchy must be righted immediately. It's a wonderful article. If you get hold of it, you should read it. This is from the mind of engineer too. So it highlights the problem that engineers have in society. He says preeminent in society, but it's not quite there yet. Not only in India, but also other countries. So in fact, what does society recognize? Right? It's always scientific triumphs. And society also recognizes engineering catastrophe. Something fails, it's always engineering catastrophe. Something succeeds, it's a scientific triumph. And then some disaster happens, it's a technological disaster. And bridge falls or something happens, engineering and technology are blamed. Science is not blamed. Of course, science is not to be blamed. Science has facts that are there, but then implementation would have gone wrong. So we always get the wrong end of the stick, a wrong end of things, right? So to be recognized by society, just like S.S. Chakrabarti said, a scientist has to discover something significant, whereas an engineer has to create a monumental entity, not a small thing. It has to be a big bridge, big building, big tower, big dam, something like that, right? A technologist might not even be noticed. Technology people not even noticed. A lot of people have worked to create something, right? But they are not even noticed. We don't even know who those are. Okay, so unless something goes wrong, right? Then I think we blame the technology. Something went wrong with the technology. Okay, that's the nature of things, right? So that's why I think I want to spend some time to just see what is engineering temper, that it should be recognized by society, or rather elevated the same way as science is elevated by society. It is not for the purpose of elevation. It is to inspire people to become great engineers. Today, a lot of young people want to go for software. That's also engineering, we can say, but that's for a different reason, because it pays off well. It's not because they can actually think creatively, create something that is not there before. That's what engineers do. That inspiration is needed. Somebody at young age, probably parents and everybody would say, oh, they tell them about great scientists and others, right? Not necessarily about great engineers, because there are so few names that float around when you say great engineers. Has it been always like that in the past? Is something that worth thinking about. So I found the answer in this NCRT book, Sanskrit book Ruchira, uh, third part, 8th standard, I think, book of Sanskrit, NCRT book, and it actually highlights something that is very interesting. It's written by a person named Anupam Mishra. He wrote it in Hindi. It was translated into Sanskrit for this lesson, and it talks about Gajadhara. Gajadharaha is somebody who Gajadharaha yaha Gaja Parimanam Dharayati sa Gajadharaha. So meaning what you see, this blue thing here is a ruler, a scale. That is Gajadhar. Like clothes people will measure how many Gaj saris or whatever, right? This is the ruler, that scale. So he holds it, so it's called Gajadhara. He's basically is someone, and in fact, if you read this sentence, Gajadhara iti sundaraha shabdaha, tadaga nirmanatranam sadaram smaranartham. So this line says that what a beautiful word Gajadharaha is. Somebody who holds a ruler, Gaj, right? That what we measure things with, right? It's a Sundaraha Shabdaha. It's a beautiful word, it says. What is it for? It is Tadaga Nirmanatranam, Sadaram Smaranatham. Sadaram, with respect, we should remember, because this Gajadharaha is associated with basically tanks in villages. Tadaga is tank, right? Talab in Hindi, Tadagam, right? So that is what people used to do. This lesson is about how these people, the Gajadaraha, Vastukaraha Asan. So they were actually engineers, civil engineers, right? They apparently used to come and go from village to village in ancient time, and a group of people will come. When they come, the whole village will respect them, because when they come here, they inspect all wells and all the water bodies, the tanks and wells and everything, and tell the villagers how the monsoon has been, how the water level is in the vicinity, and they will actually mark everything to see that in this month you will have to have water this much, otherwise you have to be careful, use water sparingly, and your agricultural things have to be planned. So when they come, the whole village used to kind of respect them, call them to their homes. They'll stay for a week or so to survey the whole thing, and people will invite them to their houses, feed them, treat them like guests. So they were respected. This Gajadaraha, this Vastukaraha, so those were all respected in those Gramina Samaj, that is olden villages. Today, I don't know whether civil engineers, for that matter, any engineer commands that kind of a respect from society. So it was okay in the past, but now it is not. And before we actually understand this engineering and science and technology, we should actually analyze the words to see what do engineers do. How do we make uh, young people now to realize when they get a degree in engineering or technology, do they actually understand what they're getting? Is it only to get a job somewhere, or do they have imbibed the spirit of engineering? So we can say the same thing about doctors. What is a medical temper? Or a lawyer, what is a legal temper? If somebody talks very logically, we say you are raising law points, we say. That is, there is a legal temper, that logic that lawyers have. And doctors, of course, when you go to doctors would talk to you for some time, and then they diagnose your ailment, they prescribe medicine. So doctors are respected, lawyers are respected. What should engineers be respected for? What is that spirit of engineering? What is that temper of engineering? Right? To understand that, let's look at some words. So first of all, I don't know how to do this. No, it doesn't go. Okay, let it be there. It will probably block a few things. Okay, now it went away. And this. So what is a scientist? No? Scientist is one who conducts scientific research to advance the knowledge in a field. Advancing knowledge in a field is what a scientist is associated with. This word is coined not too long ago. It's only 1833. Okay. And engineer or practitioners of engineering, they invent, design, analyze, synthesize, they test machines and complex systems and all of these things. Okay. And they worry about uh, the practicality and regulation, safety and cost. They fulfill all these objectives. And then another word that comes in the same way is inventor. We'll come to technology later. Inventor. Inventor is a person who creates an invention. Okay, somebody who invents. This is an inspired thing. Like we say electric bulb, we get an idea, right? That's an invention. But engineer is not just, it's much, much more than an inventor, but different from a scientist. Okay, so if you actually look at the traits of scientists, then inventors and engineers, we can actually try to distinguish three words: discovery, invention, and innovation. All three are different. Discovery is Latin root discoverir, discover, uncover. Okay, something you find unexpectedly in the course of a search, unexpectedly. Okay, and invention is also inspired, right? It's a design and create something that did not exist before. Whereas scientists find, like we define discovery and invention for school kids, scientists find what is already there, whereas inventors create what is not there. Innovation is making changes in something already that is there. Okay, either it could be discovery or invention, so you innovate. Engineers somewhat come into this innovation. It is not inspired. It's not like a 1 second thing, eureka. It's not like that. It actually is slow process. And that's why it's spread over many people and many uh, hours or days or months or years, that you cannot say, oh, this is what an engineer does. Okay, they keep on improving things, making changes in something established, introducing new methods, ideas, and products. In nowhere, make new. And invention is invenire, to come, Latin root. So you have to go to them to understand what these three words mean. And look at engineer, the way etymology online defines an engineer: constructor of military engines. In fact, engine is the root for engineer. It's about creating energy or power. Okay? And of course, there are other French engineer, architect, maker of war engines. Again, engines. Okay, this is C engine. It says engineer, C engine. So general sense of inventor, designer is recorded from early 15th century. Okay, so it's all. I mean, engineers were not there before. I mean, olden times, I said, civil engineers were there to take care of buildings and tanks and other water bodies, wells, and all those things, right? Rivers. But then only after industrial revolution came, engineering came about, and technology also came about in a way that we understand it today. And the other one, locomotive driver, that's where it came. And again, it goes back to engines, right? Maker of engines. The ancient Greek also had, right? But then people had built chariots and a lot of other things there. But then we don't associate great people to those things. In fact, we have beautiful structures, especially in Madurai. You have great temples and temple towers. So who built them? Probably don't have a name. We only say a king. Rajaraja Chola built it, right? But he was not an engineer, as far as I know. So maybe some of you know, right? So engineers are forgotten. Of course, their structures remain, which is good, right? Even when those forgotten, their structures remain, their things remain. So now let's think about technology or technologist. Technology is science of craft. It's like a skill. Techniques and processes, methods is what technology people learn. When you give a degree in Bachelor of Technology, that's what we are teaching them. We also tell them how to ensure utility, usability, safety, economic viability, and all of these things. So a technologist is one who implements technology. It also sounds like very clerical. Nothing great about it. Okay, they learn some techniques and they do routine stuff, right? So engineers and technologists are probably, that's why, relegated to something routine. Okay. In fact, if you actually look at the usage of the word engineering and technology, this is from Oxford Online Dictionary. I got these graphs. It is year 1800. Okay, engineering word started coming in 1825, 30, around that time. Before that, it was zero. No mentions in popular, media or literature, right? It slowly ramped up, then it stabilized for a while, and then increased and increased, decreased again and again. It's coming down and it's stabilizing now. Maybe it will rise, and that's what we should strive for. Engineering, if it is more and more used, that society is recognizing, or it means the engineers are doing something significant. Okay. Similarly, technology, if you see the word, came much later, right? It's the same scale, 1800 to 2019. So it started coming around 1900 and then slowly increased and reached a peak, and then again coming down and plateauing. So technology is also going, right? So in the sense that in popular mentions in newspapers and magazines, and so there are now engines that actually think about, if we type any word, it'll say how many times it is used. So we have all the data, right? That's also an engineering creation, by the way, right? A technology. So it tells you how the word is, changing, the usage is changing. So let's think about research now. We have engineering, technology, and science and invention. So we look at research as a process of creating knowledge, and of course, learning the process of acquiring knowledge. There are two different things. This is our education, because you're all, uh, most of you are also teachers. So learning is also, but it's about acquiring knowledge, whereas research is creating knowledge. Who creates knowledge? So only scientists create knowledge? Not true. Discoveries lead to knowledge, and inventions also need knowledge. Engineering also leads to knowledge. Everybody creates knowledge. Okay, but I'm showing these arrows. Discovery and invention are fed into engineering, and engineering is fed into technology, right? So but technology not create knowledge, technology also creates knowledge, right? That arrow I have not shown, but mostly it will be the routine part of implementing something. So if you look at discovery, invention, engineering, technology, uh, then actually we can think about with a way that we can understand. Before that, let me just say, here is a little cartoon from Calvin and Hobbes. So Calvin is asking his parents, how do they know the load limit of bridges, Dad? He's asking his father, because seeing the sign, load limit is 10 tons. And the father finally says, they drive bigger and bigger trucks over the bridge until it breaks. Then they weigh the last truck and rebuild the bridge. Right? That is funny. Sounds funny that, they would have built 100 bridges, okay, until they find out for 10 tons it doesn't break, and that's how they put the limit. That's not how engineers work. A lot of thought goes into it. To build a bridge or a building or whatever, a lot of thought would have gone in, and based on that it is done, right? So engineering is not trivial. So what is the thing about research, because we talk about scientists are associated with research. Are engineers not associated with research? What kind of research do they do? And technology, what kind of research do they do, right? So I would like to have these three words. We could actually use many other words. I just chose these three words: observation, contemplation, and implementation. Contemplation can be analysis and synthesis. Okay? So why did I choose these three words? So a scientist starts from observation. They're curious. Right? If you're a scientist, you're curious about things around you, look at everything and you examine, you try to infer something, and you might discover something new. So it's always about observation. That's why if you say scientist, icon will be a microscope, a biologist, for example, okay, or a telescope if you're an astrophysicist or something, right? They observe, and then they would do analysis and so forth, the contemplation, and they might implement also something, but their starting point is observation. Whereas engineer, we can argue, observation already done. Now we contemplate, we analyze things, we simulate things, we synthesize things, we create things. We start with contemplation, and then implementation is kind of a technology thing. And then you might actually observe something new and discover also. It's not like engineers do not discover things. Okay, but the starting point is contemplation. You see, inventors will start with the implementation, and then there may be some observation, and there could be some contemplation also. But they would just, light bulb, they want to make the light bulb right away. That's the implementation. Okay. Now, if you put them along a circle, so observation, contemplation, implementation, I would say an engineer starts there in the contemplation, okay? Whereas scientist would start with observation, and a tech inventor will start with implementation. It gets an idea, starts building it without any analysis or synthesis, just inspired thing. Okay. But somebody who does all three are complete researchers. We don't have to categorize them as they are scientists, engineers, or inventors. Everybody is creating new knowledge. So somebody who does all these would be complete researchers. Okay. But actually, if I put these three and then put something around it, they all feed into technology. Scientists lead to technology. We have seen this vaccine thing now, and engineers, of course, do. They had a big role to play in this vaccine thing also now. Also, implementation finally. That's only technology. Technology is kind of encompassing all three things. Okay. So technology actually is the one that creates products that improve the quality of our life with many things. Okay. And another thing to observe is that engineering, for every engineering discipline, there is an underlying science discipline. There's something we need to remember. In a way, I would say science usually bites and leaves it. Okay. Engineering actually chews on that. Whatever discovery that science finds, it's just like one bite, then leave it. Okay. Engineers go and chew that a lot to really get the juice out of it. And then technology actually the one that digests. That's how one can look at science, engineering, and technology. Okay, so there is this thing about somebody who finds an apple and bites it is probably given more credit than somebody who chews and finally technology would digest it. These things are taken for granted, whereas first thing is given the thing. One way to look at it. Okay, and one can also say engineers are practical scientists. Okay, because they also do this observation, contemplation, and implementation, but they are practical scientists. And somebody else called them analytical artists, because engineers create things. So creation is associated with artists, but they're analytical artists because we have a lot of physics and biology and chemistry, all the science we take and mathematics, and then analytically we create things. They're called analytical artists. Okay. Now let me come to the temper. That's what I want to tell you about the temper. So temper is also has a lot of roots. Latin root is temperare. It is a mingle, a restraint. And Old English has this bring something into required condition. Old French says moderating, like tempering. We say in cooking, like tempering. So temper is a state of mind. It's a mood, and it's a way of thinking, way of life, way of behaving and acting. And that's why I want to see whether engineering temper is properly communicated to our students today when they're actually studying engineering, right? Because we teach them a lot of science and we teach them some technology and some engineering. So somewhere some things get lost. So how do we make somebody gets a Bachelor of Engineering, a Bachelor of Technology degree? Do they have that temper in a similar way a lawyer has, or a doctor has, or a scientist has? Okay. So before talking about engineering temper, I'd like to talk about scientific temper. That's used more often than engineering temper. Okay. So this is again the way of life, it says. Okay, individual and social process of thinking, which is a scientific method, and which may consequently include questioning, observing. That's what I said, observing physical reality, testing a hypothesis, and then analyzing and communicating. Not necessarily in that order, it says. It's about questioning, observing, and so forth. That's scientific temper, right? And you don't take anything for granted. You question, try to understand. Then what is engineering temper is what I would like to tell you. Before that, the scientific temper, interestingly, was apparently popularized more than anybody else by Pandit Jawaharlal Nehru. In his book, Discover of India, where I have taken this passage from, he talks about the temper of a free person, a temper of science. Okay, again the same thing, the capacity to change previous conclusions in the face of new evidence, the reliance on observed fact and not preconceived theory. You don't take it for granted. You have to observe and see for yourself. That is scientific temper. That's what everybody says a country should have scientific temper, which is what Nehru had tried a lot soon after independence. And that's why we had a lot of things, initial conditions set right, and we had a lot of progress at that time. Okay, in the book, Discoverer of India, he talks about science deals with the domain of positive knowledge, but the temper goes beyond that. That is something we need to remember. See, science deals with some facts, that is their knowledge. But he says the temper goes beyond that. In a similar way, when you talk about engineering, engineering temper should go beyond what we learn. If you are ECE department, you teach a lot of subjects in it, electronics, communication, engineering, like you teach a lot of subjects. But a student who learns all that acquires that knowledge, but then should also get that temper that goes beyond the domain. Nehru gives examples. A botanist or zoologist may never experience the charm and beauty of nature. They would have studied plants and animals, but they may not enjoy the beauty of nature. That means that they have not gotten that temper of a botanist or a zoologist. Okay, and that's what he talks about. You know, it's a normal person who is not a botanist zoologist. When we go to the regions beyond the reach of scientific method and visit the mountain tops where philosophy dwells, emotions fill us, or gauge at the immensity beyond, that approach and temper are still necessary. You don't have to be a botanist zoologist to appreciate nature, right? That is a temper. You may not know botany and zoology, but you appreciate things. And similar way, what is engineering temper is what I would like to explore today. Okay, again, scientific temper in daily lives. You know, when we talk about, we look at the starry night sky. This is a scene from Swadesh, which is a very nice scene. The villagers will be watching a movie, and uh, suddenly power goes off, and everybody is agitated. Children are distracted. Everybody makes noise. And Shah Rukh Khan suddenly takes his telescope, turns to the starry night sky, shows everyone, and excites them about science. So there is scientific temper, right? So he just, because he's a scientist, he just immediately thinks of this and does it. And a whole village actually enjoys that moment of looking at the starry night sky, right? But now let's come to engineering temper. See, if I type engineering temper in Google, that's what we do. If you want to know anything today, we just go and type it in Google. When you do that, he actually talks about metallurgical tempering. Yeah, I don't know, maybe there are some metallurgists or materials engineers amongst you would know tempering, that we say tempering of steel, heat treatment. That's what you get. And a lot of things you get. And of course, in cooking, also tempering is there. So you see a lot of mostly heat treatment or cooking. That's what tempering you get. Engineering temper. You don't get anything more. That phrase itself, engineering temper, is something that is not very popular, whereas scientific temper is. Okay. Um, so what do engineers do? They create things. They improve understanding of a concept. They use science to solve problems. Problem solving is what engineers do, and they have to do so under constraints. But they also perfect a technique or a method. Okay? So the traits of an engineer are creating something, synthesizing things. You acquire a lot of piece of knowledge, synthesize that to solve problems. You make things, and you make things better. That's engineering, right? To see, if you are an engineer, you would say, she would ask, how can I solve this problem? How can I make it better? Or you would say, how is it made? Right? That's also a question that you have. How can I make it better? So let's take an example. So the person I'm showing here is Ørsted, Hans Christian Ørsted. He's the one who found that when you pass electric current in a coil, that creates magnetic field. After that, how many people would actually invent or create calling bell? Right? We have calling bell every day. So when we teach them about the link between electric current and magnetic field, so once you get that, that's like a discovery, right? Ørsted, is one unit is there named after him, immediately comes here. So somebody has to think about that. When you think about that, then you have to say, what should be the magnet here? What should be the strength of the magnet? How many coils should be wound here? How much current should be passed? How much force is needed for this to move? And when the sound is produced, what materials do you use here? There's a lot of engineering. After all that engineering, then you have to make a calling bell as a mass production. That's all technology, right? So science, you start with Ørsted science and do this, or look at this. This is Tesla, one of America's greatest engineers, who basically brought electricity to America, right? Hydroelectricity and things that he did. He was a great engineer. He worked for Thomas Edison, and they had some quarrel between them. And then he became much bigger than Thomas Edison himself. who actually the other way around. When you put a magnet and spin, you get generate electric current, power generation. So both ways, science does something, discovers, and then from Oersted to Tesla, the engineering came to the top. And that's what engineering is. Like I said, science bites, engineering chews. Okay. I think another example, laser. Laser is a discovery invention. That is science. Somebody got a Nobel Prize for that, right? But then that itself will not do anything that you want to do with lasers. Right? You need a lot of engineering. So how do you create a laser of intensity that you want and wavelength that you want, right? And then how do you produce it? All that has to be engineering. A lot of this is just a bite, is a lot of chewing. Technology, of course, digests it, meaning now I have this laser pointer and I have laser displays, laser surgery, laser manufacturing, lots and lots of applications. That's all technology. It's digesting the discovery. Engineering is then between from that little bite to the complete digestion. That's all engineering. You can give these examples of anything. It's the landfills. Today we produce a lot of solid waste, right? So how do you deal with it? It's a big problem. It's a society's problem, right? First of all, you need to have science. So all this solid waste, what can you do with it? If you just burn it, it's going to cause other problems, right? Pollution. So you have to biodegradable thing, you have to find it, or some other process you have to get it. Some chemistry, biochemistry. How do you gasify solid waste? That is science. After that, how do you do that in a way that you do it economically? You don't want to use energy again to convert a solid waste to gasification, not too much energy. There's a lot of engineering there. Finally, the technology will be there, the biomass gasification. So if we take any of those things, right, there will be science, engineering, and technology. Engineering is the longest period, right? That's where chewing, I call it chewing, okay? And we can also ask the question, can engineering stand without science? Okay, this is well said by an Australian professor, William Charles Kernot. Not many people might be aware of him. The theory and experience are of equal importance to the engineer. Theory we associate with science, and experience is practice. Both are important for engineer, he says. And he says, theory without experience is the foundation without the superstructure. You just have the foundation, that's all. Science takes a bite and leaves it. There's nothing on top of it. On the other hand, experience without theory is a superstructure without the foundation. Right? That's also important. If you want to do something, you cannot just go like an inventor, invent it, but you need a solid foundation below. He says the former is useless. That is, if we just have a discovery, that's useless. The latter is dangerous. We just have, something built without much thought. That's dangerous. You cannot have a building without a foundation. So engineering always has to stand on science. That's why we probably give more credit to science than engineering. But then here I'm showing a few famous engineers. All these people, I don't know how many of these faces are recognized, in the audience today. It's difficult because, especially during the time of James Watt, everybody looked alike. And this probably some of you might know because most of you are from ECE. This is Maxwell. And this is Eiffel. Somebody said Eiffel already. And this is Buckminster Fuller. And this is A.J.M. Mitchell. He's an Australian engineer. He's an American inventor, designer, and engineer. There are many more things. I just have a few of these people to talk about their great engineering. Of course, first with Eiffel. Okay, Eiffel Tower. So Eiffel Tower is a remarkable structure. It has optimality in it, and I can talk for an hour about it. He was a great engineer. Eiffel was a great engineer. It was not just the tower that he built. He actually built a lot of bridges in Europe and a lot of buildings as well. And if you show me one of Eiffel's thing, I can immediately recognize that it is Eiffel's. Just like if somebody shows Ravi Verma's painting, you say that must be Ravi Verma's painting. That is Picasso's painting. That's M.F. Hussein's painting. There's a characteristic signature of Eiffel in all his designs. The cross beams and very optimal. Today, people are going back to Eiffel's designs, right? And this is one of the famous bridges that Eiffel had built. It is still there in Portugal. And our own bridge in Howrah, right, in Kolkata, that has features of Eiffel's great design, this hierarchical design. So Eiffel's legacy is continuing to say that Eiffel's Tower is actually a piece of beauty today. That George Seurat had these little points that he put and makes a painting. Similar way, Eiffel put these little beams here, there, created a beautiful structure. So today, whenever you go to Paris, we always want to take a selfie near the Eiffel Tower. It's just a building. It's an icon of beauty. So engineers also create beautiful things now, right? And Maxwell, right, is a famous scientist, right, physicist, but there was an engineer in Maxwell. Okay, in fact, we use these reciprocal figures and frames and diagrams of forces that Maxwell did for optimization. Okay, for using this, these actually the William Baker is an architect who designed Burj Dubai. Something that very big, then we'll say who did it. But regular bridge, nobody cares, right? So this William Baker, uh, he is using Maxwell's engineering contributions in designing structures today. And some of these things are all attributed to Maxwell's imagination. So Maxwell is a great scientist, but he was also a great engineer. And these also, all of these goes back to Maxwell. And there is this A.G.M. Mitchell, who was also inspired by Maxwell, who was a great Australian engineer. And he begins with Maxwell's theorem in his paper, because Maxwell has shown that. This is 1904. And it's all about structural optimization. Engineer, A.G.M. Mitchell. And Mitchell was a great engineer. Whatever they did at the time, today we get through a lot of mathematical optimization, we get similar designs. And we call this homogenization method, and additive manufacturing is after this topology optimization. All this was done by actually credited to Maxwell, and then other people are inspired. So here is a scientist who has inspired a lot of engineering. And this A.G.M. Mitchell himself did a lot of things. There is a Mitchell Bearing Company which celebrated 100 years in 2020. And this was not simple invention. It was actually, he read great scientists like Oswald Reynolds. We have Reynolds number Reynolds in fluid mechanics. He read his papers, understood the theory, and not just invention of tilted pad thrust bearing. And it was not just invention like electric bulb. A lot of mathematical theory went into it. Okay. Similarly, when Mitchell did this continua, it started with Maxwell. So practice always rests on theory. So engineering practice stands always on the shoulders of great theories. So that's why science and engineering go together, and we miss the point in between. Okay. So we can say engineers inhale science and exhale technology. Okay. So engineers come in between. And occasionally, engineers also exhale science. And I'll give you examples of that. And sometimes art too, I feel, is one of those. So engineers can actually lead to scientific discoveries, and they can also create pieces of art. Great buildings, architects do that all the time. We want to take a selfie with those buildings, right? They create art as well. So the engineers inhale science, they take scientific discoveries and then exhale technology. And that's how we should look. And somehow that seems to be routine for many people. James Watt, no, he was a quintessential engineer, person who played a big role in industrial revolution, first industrial revolution, because of engines again, right? And he created a lot of linkages as well. And lot of things that we actually call them Watt's linkage and so forth, right? And there is a centrifugal governor, that closed loop control is also attributed to James Watt. He was a great engineer, right? Centrifugal governor. And then he actually made, if you give a three-dimensional object, he had a mechanical thing like a sewing machine. If you push on this pedal, it'll actually carve out the three-dimensional replication. If you give a three-dimensional object, there'll be one stylus going over it, another one if you have put a clay, right? It would actually carve that, or wood, it will carve that. He had created lots and lots of interesting machines. But James was a great engineer. In fact, in Metropolitan Museum of Science in London, Science and Technology maybe in London, there is a big hall just for James Watt. He was a great engineer. This great engineer also had a scientist in him, right? Scientist in James Watt. It is something that somebody wrote, Archibald Barr. So he said, we have written about, I and my student Deepak have written about James Watt. Watt's life is a consummate example of a craftsman turning into an engineer and an engineer turning into a scientist. That's what I meant. Your starting point is contemplation, but then you can also go to implementation, which James Watt did. And then he went and completed the full circle of becoming a scientist as well. Okay, James Watt did a lot of mechanical engineering, and then he also did science. So chemistry, for example, James Watt was apparently one of the first people to suspect that water is a compound and not an element. So during his time, the steam engine, he was working with steam, water turning into steam. So he didn't stop at making steam engines or other machines that he created. He also wondered about the nature of steam or water. He said it's not an element, it's a compound, right? That means that he had a scientist's mind also in him. That happens naturally in many of us as well, right? And of course, finally, the Buckminster Fuller. He was a great designer and engineer. He invented lots and lots of things right from his childhood. And then there is I've written about about him also, the fabulous designs that he created. Whether he looks at a boat and looks at and comes up with a new design, and is actually called a space truss, that element that Buckminster did. Uh, and the bricks that we use today to have this ventilation, so for insulation and so forth, and light weighting, get designed and invented lots and lots of things. And it goes beyond that. No? For example, if I show this, some people will think it's like Japan, some island. Actually, it's not. It's actually a world map that he had basically found out, because the globe or Earth is round like a ball. Whenever you say a map, right, it's always distorted. Some Antarctica, things like that, they look much bigger than other places, right? So everything is distorted. But how do you project it? He had a projection of the spherical thing onto a flat one using a particular thing that I'll show in another slide, right? This the globes, that big structures, figurines as we call them, that science actually celebrated that. He had predicted these things, right? And then he had this temper of an engineer in him, that he would talk about a house, what he called Dymaxion, and that was the word he coined. He worked quite a word also, with a dynamic maximum, that is like optimization. Ion, just to give a sense of science, ion in chemistry, we have ions called Dymaxion. He actually feels it's called Dymaxion man. He had a Dymaxion car, Dymaxion house, and Dymaxion toilet. So everywhere he put in his engineering spirit. That is the temper. Whatever he did, he thought like an engineer, right? And a great example of an engineer. And this is the projection that he had. If you were to take a sphere inside and put these walls around it and project the Earth, that round thing, onto these, and develop this icosahedron, 20 triangular faces, then world map looks like this. Okay, so with everything as if it is connected, it's a great view, and it's a least distorted map of the world. And he has the temper. Whatever he looks at it, he didn't like the globe the way it is, and then a map. Globe, of course, is fine, but when you make a flat map, he was not happy with it. He came up with his own way of looking at it, and that's kind of engineering spirit. Not only that, he also thought about looking at the globe. He said, from which point above Earth, if I look at it, okay, go around the Earth in a satellite or something, from which point above I would see most land mass or most water, right? And that's how he looked at apparently one point here in France, somewhere, Riviera. If you right above it, you would see the most land mass. He asked all these questions, and that's all the curiosity questions that scientists would ask. But he also did, like an engineer would, finally, to see if you were to connect all the Earth with the power grid or energy grid, so that there's minimum amount of path here. He had done this, his projection of the Earth from a globe to this using the icosahedron thing, and he did that with geodesics drawn. And this is the best one, he says. And that's the how you should do. You minimize the the grid, and hence the loss as well. As electronics engineers, you would appreciate that as well. So he also Dymaxion projection. So he coined the word Dymaxion and got it into everything I did. And that's how we should be if you're an engineer. So the scientific temper is looking at the stars and wondering what they are. What is the engineering temper, right? So engineering temper, I would say, is one example. He is Awais Ahmad. He's a BITS Pilani graduate. When he gave a talk in IISc in 2020, he was barely 22 or 23 years old. He's the CEO of this company called Pixel. What is he doing? His company is seeing the unseen. So he wants to put hyperspectral smart satellites, a constellation of it, right? If scientific temper is looking at the stars and then say what those are and what they are made of, when were they born, all the curiosity questions are the science questions. An engineer should look at the stars and not stop at admiring the stars or understanding the stars, but actually creating a constellation of small satellites with which he wants to see what is under the earth. And you can the coastlines, and he has a big list of things that he wants to do with this. And he got funding from Elon Musk's, one of the great engineer of our time, right? So got the funding to do this. His company is based in Bangalore. That is, I would say, that is engineering temper. Not be happy with understanding, but actually creating that. And of course, I want to end with Elon Musk, right? Great engineer of our time. And he's a bold engineer. He can make rockets go up and come down vertically and land on a ship or land anywhere. And think of Neuralink, think of Hyperloop, lots and lots of engineering. This resurgence of real engineering is what we want. Software is great, but unless we get this or imbibe the spirit of engineering temper, our future generation people would not be doing real engineering. So I can see that the uh, enrollment in traditional engineering disciplines, civil, mechanical, materials, and chemical, is dropping. Whereas computer science, maybe electronics, you are fine. But then real engineering is creating things, real things, right? And we hope for this resurgence of real engineering. So I'll stop here and thank you for listening. And I'll be happy to answer any questions. Thank you.
Thank you, sir. Uh, Participants, if you have any doubts, please do unmute yourself and you can raise a question, or you can even put it in the chat box. You have provision to unmute yourself and raise any question.
Hi, sir. This is Neeraj here.
Mhm.
My question was that even in our corporate lives, we come across this term engineering mindset, and we are like expected to look at problems in a way, in a different way, and maybe break them down and then try to figure out some things out of them. So, how do we actually do that? From what we have learned, maybe in our formal education and what we experience in our day-to-day lives.
Yeah. So, like I said, once you understand something, you acquire some knowledge, you have to think about applying it. Okay. And applying in a way that you create something that is not there. That is the engineering temper or engineering mindset, as you called it, right? Or making things better. You don't have to create new all the time. It's not possible either, right? You can make it better, or at least be curious as to how things work. Okay, how things work, there is a difference. How does nature work? You may wonder, you may look at a plant and then see how does a seed lead to a plant or a tree. That is curiosity about the natural things. But similarly, if you look at a washing machine, do you ever wonder how does it work? Right? Something is spinning, but spins at a very high speed. It has to be balanced well. How is it balanced? It makes noise, but these days washing machines make less and less noise. Can you improve it? If you're a mechanical engineer, you have to ask that question, right? If you're an electronics engineer, you would ask a question related to that. And that is what I would call it engineering mindset. Yeah, of course, engineers are problem solvers, right? Based on what you learn, don't be content with learning, but actually learn how to apply and improve the world around us. Does it answer your question, Neeraj?
Yeah, yes, it does.
Yeah, I see Dr. Manoharan's comment here that temper is not much because there are silos in our academic system, separate engineering and science. That's absolutely true. Like I said, great people, whether they are originally engineers, can do science, scientists can do engineering. So we need to actually bridge that gap so that people understand, society understands science very well. They don't understand engineering. So we have separated, but then we have to put together, but each should have its distinct flavor. Any other questions? Yeah, maybe I will ask a question. Why do you think engineers do not command the respect that scientists command in society? Again, the idea here is not to go for the prestige associated with the respect, but it's actually encouraging people who are learning engineering, which is a large number in the country today, in our country or the world. So how would they be inspired to do their best? Okay. Yeah. Thank you very much for your attention.
Thank you, sir.
Thank you.
Thank you. Good evening to all. I would like to say a few words. As a part of IEEE MTTS Micro Theory Techniques Society Student Chapter TC Madurai, I thank management, principal, and head of EC Department TC for giving an opportunity to conduct the first lecture series. I humbly thank our directors who are also and chairperson of IEEE MTTS Madras section, who has been a constant motivator and inspirer.